Imagine, if you will, a silent voyager hurtling through the endless void of space, a speck of ancient mystery wrapped in dust and gas, racing toward our sun from the farthest reaches of the galaxy. This isn't the stuff of science fiction. It's happening right now, as of October 14th, 2025. Welcome to the tale of 3I/ATLAS, the third interstellar object to grace our solar system, a cosmic enigma that's challenging everything we thought we knew about the universe. Picture it: a rocky wanderer, older than our own solar system, shedding water like a fire hose and glowing with an otherworldly chemistry. It's not just a comet, it's a messenger from the stars, carrying secrets that could rewrite our place in the cosmos. Stick with me through this journey. It's going to be a wild ride, full of wonder, questions, and that spine-tingling thrill of discovery. If you're as captivated as I am, smash that like button right now, and let's dive in together. It all began on a crisp night in Chile, July 1st, 2025, when the Atlas telescope in Rio Hurtado pierced the darkness and spotted something extraordinary. There, against the backdrop of the Milky Way, was 3I/ATLAS, a blurry dot moving at breakneck speed, over 130,000 miles per hour when first detected, screaming outsider with every calculation. Astronomers' hearts raced as they plotted its path, a hyperbolic orbit, too fast for the sun's gravity to capture, meaning this visitor was on a one-way ticket through our neighborhood, never to return. Can you feel the excitement? That moment when data streams in, and suddenly, you're staring at a piece of another star system, possibly billions of years old, forged in the thick disk of our galaxy, a region teeming with ancient stars and forgotten worlds. This wasn't just any find. It was the third confirmed interstellar object, following the cigar-shaped Oumuamua in 2017, and the more comet-like 2I/Borisov in 2019. But 3I/ATLAS felt different from the start. It activated early, brightening in May 2025 at about 6 astronomical units from the Sun, beyond Jupiter's orbit, where most comets slumber in icy silence. Why so soon? Scientists puzzled over it, their minds buzzing with possibilities. Was it packed with volatiles that sublimate at lower temperatures, or something more exotic? The emotional weight hits hard here. Imagine the loneliness of this object, drifting through the cold interstellar medium for eons, only to awaken near our warm star. It's a story of resilience, of survival against the cosmic odds, and it pulls at our human curiosity like nothing else. As observations poured in from telescopes worldwide, the picture sharpened. By August, the James Webb Space Telescope turned its infrared gaze on the comet's coma, that fuzzy atmosphere of gas and dust, and revealed a dominance of carbon dioxide, 8 times more than water vapor. 8-1. In our solar system's comets, water rules the roost, but here, CO2 takes center stage, hinting at a birthplace far different from our own. Researchers like those at NASA's Goddard Space Flight Center marveled at the data, their voices tinged with awe in press releases. "This is rewriting the rulebook," one said. And the isotopes? The carbon-12 to carbon-13 ratio mirrors Earth's, suggesting a familiar chemistry in an alien package. Paradoxical, isn't it? Exotic yet eerily similar, like finding a long-lost relative from across the ocean. But let's not rush ahead. The discovery ignited a global frenzy. Amateur stargazers pointing their scopes, professionals scrambling for telescope time. If this stirs your sense of adventure, drop a comment below. Have you ever spotted a comet? Share your story. And if you're hooked, subscribe for more cosmic tales. We're just getting started. As we transition from the thrill of detection to the echoes of history, remember, 3I/ATLAS isn't alone in its strangeness. It's part of a lineage that's been teasing us for years. To truly grasp the drama of 3I/ATLAS, we must journey back to its predecessors, those interstellar pioneers that first cracked open the door to the galaxy beyond. Rewind to 2017. Oumuamua bursts onto the scene, a cigar-shaped oddity tumbling through space without a coma, defying every comet stereotype. No tail, no gas outbursts, just a silent, elongated rock accelerating in ways that sparked wild debates. Was it a shard of a shattered planet? A hydrogen iceberg? Or, as Harvard's Avi Loeb boldly suggested, an artificial probe from an alien civilization? The scientific community erupted in discussion, emotions running high, skepticism clashing with wonder, fear of ridicule, battling the thrill of what if. Then came 2I/Borisov in 2019, more conventional, yet still alien. Discovered by amateur astronomer Gennady Borisov, it sported a classic coma and tail, spewing dust and gas like a proper comet. But its origins? From another star, wandering into our system like a lost traveler. Observations showed it rich in carbon monoxide, hinting at formation around a cool red dwarf star. The emotional layer here is profound. These objects remind us of our isolation, yet connect us to the vast cosmic family. They're time capsules, carrying the chemical fingerprints of distant births, evoking a deep sense of humility and unity with the universe. Now 3I/ATLAS joins this elite trio, but with its own twists. Unlike Oumuamua's barren form, it has a vibrant coma. Unlike Borisov's orthodoxy, its CO, to dominance and early activity, scream uniqueness. As of October 2025, with its Mars flyby behind us, captured in stunning detail by ESA's ExoMars Trace gas orbiter on October 3rd, we're seeing a comet that's leaking water at 88 pounds per second, a fire hose of activity that's both mesmerizing and puzzling. The images show a fuzzy blob streaking across the Martian sky, stars trailing like whispers of the past. How does this fit the pattern? It doesn't. It's evolving it, pushing us to question models built on solar system norms. Feel that pull? The history of these visitors isn't just facts. It's a narrative of human perseverance, of gazing up and daring to dream. If this chapter has you pondering our place in the stars, hit that share button. Let's spread the awe. As we move from history to the mechanics of 3I/ATLAS's wild ride, prepare for the math and magic of its orbit. Picture this: a bullet fired from the galactic rifle, slicing through our solar system on a trajectory that's as precise as it is improbable. 3I/ATLAS's path is hyperbolic, a mathematical marvel, meaning it's unbound by the sun's grasp, slinging past at speeds now clocking 67.5 kilometers per second as of October 14th, 2025. When first spotted, it was zipping at over 130,000 miles per hour, tilted almost backward, a steep incline that sets it apart from our orderly planetary plane. UCLA astronomer David Jewett's words echo. It's like glimpsing a rifle bullet for a thousandth of a second. No chance to trace its origin precisely, but calculations point to the Milky Way's thick disk, a stellar nursing home of ancient stars, making 3I/ATLAS potentially 7 billion years old, older than our sun. The emotional depth? This path evokes transience, a fleeting encounter that mirrors life's brevity. It passed Mars on October 3rd at 18 million miles, allowing orbiters like Mars Express and ExoMars TGO to snap photos, grainy yet groundbreaking, showing the comet as a bright dot against streaked stars. No close Earth approach, thankfully. Its nearest to us is about 168 million miles, but the geometry gifted us this Martian vantage. Spectrometers aboard detected gases, complementing Earth-based data, building a fuller portrait. But why this path? Hypotheses abound. Ejected from its home system by gravitational tugs, wandering for eons until our sun's pull drew it in. The tempo builds here. Slow wonder at the vastness. Quickening pulse as we realize how rare this is. If you're geeking out over orbits, comment your favorite space fact below. Transitioning smoothly, let's uncover the chemical heart of this beast, where the real surprises lurk. Dive into the molecular soul of 3I/ATLAS, and you'll find a chemistry that's as baffling as it is beautiful. JWST's August 6th observations unveiled a coma rich in carbon dioxide, with an 8-to-1 ratio to water, extreme even compared to oddballs like C/2016 R2. Why so much CO2? Theories swirl, perhaps formed near its home star's CO2 snowline, or altered by cosmic rays during its long exile. The Very Large Telescope detected cyanide and nickel vapor, akin to solar system comets. Yet the isotope ratios match Earth's carbon, blending familiar with foreign. Then there's the water. As of October 2025, it's gushing at 40 kilograms per second, a fire hose running at full blast, per recent studies. This activity started far out, at 6 astronomical units, defying norms where water ice needs closer solar heat to sublimate. Emotional layers? It's like witnessing a rebirth, the comet, frozen for billions of years, now alive with vapors, shedding its ancient skin. Hypotheses: a thick crust trapping water, cracks letting CO2 escape first, or radiation-induced changes. The dust? Uneven, a teardrop cocoon facing the sun, as Hubble's July 21st image showed. A hazy glow with a sunward plume and faint tail. This geometry explains the odd appearance. Dust blowing toward the sun, curving under pressure. Size refined. Nucleus between 440 meters and 5.6 kilometers. Dark and reddish, reflecting just 5% light, rich in organics. The narrative energizes here. Facts piling like building blocks, each revealing more mystery. If this chemical dance fascinates you, like and share to fuel the conversation. Now, let's zoom in on that dusty shroud, where visuals tell the tale. Hubble's lens on July 21st, 2025, captured 3 I/A TLAS at 277 million miles from Earth, revealing not a symmetric halo, but a teardrop dust cocoon, elongated like a fan toward the sun. The bright head, uneven distribution, plume sunward, weak tail opposite, flips the textbook comet image. Why? Geometry and first-time warmth. Racing in at a steep angle, releasing dust sunward, bending slightly. Jewett noted heavy dust release at 4 Earth-Sun distances, unusual for its size. Emotional resonance. This shroud feels protective, a veil hiding secrets, evoking vulnerability in the vastness. The image, a striking photograph of hazy glow, refined size. Estimates: upper limit 3.5 miles, possibly smaller if dust dominates light. Dark reddish surface suggests organic-rich material, like Oumuamua and Borisov. The tempo slows for reflection, beauty in the asymmetry, lessons in expectation subversion. Comment: what does this image make you feel? As we shift to the Martian encounter, excitement builds anew. October 3rd, 2025, dawned not just on Earth but across the solar system as a pivotal moment in astronomical history, a cosmic rendezvous that bridged worlds and ignited imaginations worldwide. As 3I/ATLAS hurtled past Mars at a mere 18 million miles, closer than many comets ever get to our planetary neighbors, humanity's robotic emissaries on the red planet sprang into action, their instruments whirring with purpose against the rusty backdrop of Martian dunes and craters. This wasn't just an observation, it was a symphony of international collaboration, with spacecraft from Europe, the United States, and potentially China turning their electronic eyes skyward, capturing glimpses of an interstellar interloper that could unlock the secrets of distant star systems. Imagine the tension in mission control rooms across the globe. Engineers fine-tuning orbits, scientists holding their breath as data packets beamed back across millions of miles, each byte a potential revelation. Leading the charge were the European Space Agency's veterans, Mars Express and the ExoMars Trace Gas Orbiter, TGO, which pivoted from their usual duties of mapping Martian terrain and sniffing for atmospheric gases to this once-in-a-lifetime target. Between October 1st and 7th, these orbiters executed a meticulously planned campaign, their high-resolution cameras and spectrometers locking onto the comet's faint glow. The TGO's color and stereo surface imaging system, CASIS, stacked multiple exposures to create a mesmerizing sequence, showing 3 I/ATLAS as a fuzzy, ethereal dot descending across a field of streaked stars. a visual poem of motion that captures the comet's relentless speed. From this vantage, closer than any Earth-based telescope could achieve at that moment, the images revealed subtle asymmetries in the coma, hints of structural details that ground observations had only hinted at. The emotional surge here is palpable. These machines, launched years ago to study a dead world, suddenly became witnesses to a living cosmic drama, extending humanity's reach beyond our blue marble. But the story doesn't stop with Europe. NASA's fleet joined the fray, repurposing instruments on the Mars Reconnaissance Orbiter, MRO, and the MAVEN spacecraft, which typically probes the Martian atmosphere for clues to its ancient habitability. Even the Perseverance rover, roving the Jezero crater in search of signs of past life, might have caught a fleeting streak in the Martian sky if conditions aligned. Though unconfirmed, the idea alone stirs a sense of wonder, blending the search for extraterrestrial life with this visitor from afar. China's Tianwen-1 orbiter, with its own suite of cameras, could have contributed, turning this into a truly global interplanetary initiative. Picture the data flowing back. Spectra showing molecular fingerprints of water vapor, carbon dioxide, and perhaps traces of carbon monoxide, building on JWST's earlier findings and painting a more complete picture of 3I/A-TLAS's volatile composition. What did scientists hope to gain from this Martian perspective? At 30 million kilometers, still a vast distance but a fraction of Earth's view, the resolution allowed for rough estimates of the nucleus's shape, confirming its near-spherical form without the dramatic brightness variations seen in elongated objects like Oumuamua. Color data complemented Hubble's visuals, revealing the comet's reddish hue, a telltale sign of organic tholins baked by eons of cosmic radiation. If gas emissions were strong enough, spectrometers like those on TGO could detect isotopic ratios in real time, offering clues to the comet's birthplace, perhaps a system with a sun much like ours, yet with a wildly different ice balance. The implications ripple outward. Understanding these volatiles could tell us about the building blocks of planets elsewhere, maybe even the delivery of water to alien worlds, echoing how comets might have seeded life on Earth. As of October 14th, 2025, with the comet now hidden behind the sun from Earth's viewpoint, disappeared into solar conjunction, and not expected to re-emerge until early December, these Martian observations have become even more precious. They provide continuity in our watch, a bridge over the observational gap as 3I/ATLAS approaches its perihelion on October 30th at about 1.4 astronomical units, roughly 130 million miles from the sun. The emotional layers deepen here. In a time when humanity grapples with division, this coordinated effort reminds us of our shared quest for knowledge, a beacon of unity under the stars. It's not just data. It's a testament to ingenuity, turning distant probes into impromptu comet hunters, practicing for future intercepts that could one day sample these wanderers up close. And the excitement doesn't fade with Mars. Farther out, ESA's JUICE probe, en route to Jupiter's icy moons, geared up for its own observations in November, despite thermal constraints limiting its gaze. From a cooler, safer distance, JUICE's instruments, cameras, spectrometers, and more aim to catch the comet post-perihelion, when its activity might peak, shedding more light on its dust and gas dynamics. NASA's Lucy mission, bound for the Trojan asteroids, has been floated as another potential observer, its path aligning just enough for a sidelong glance. This chapter pulses with the energy of collaboration, a reminder that space exploration is a team sport, spanning agencies and continents. If this interplanetary ballet has you thrilled, smash that like button and comment. Which spacecraft do you think captured the best view? Share your thoughts. As we glide from this red-tinted rendezvous to the shadowy whispers of speculation, prepare for a dive into the what-ifs that make astronomy so endlessly captivating. Whenever an interstellar object streaks into our headlines, it inevitably stirs a cauldron of mystery, speculation, and that irresistible human urge to wonder, what if it's not natural? With 3I/ATLAS, the whispers began almost immediately, echoing the fervor that surrounded Oumuamua in 2017. Harvard professor Avi Loeb, never one to shy from bold ideas, revisited his controversial theories, pointing to the comet's unusual sunward glow, its high CO2 content, and its finely tuned trajectory as potential signs of something engineered, perhaps an alien probe or spacecraft, fine-tuned for a flyby through our system. The emotional pull is undeniable. In a universe so vast and silent, the idea of visitors from afar taps into our deepest hopes and fears, evoking scenes from science fiction where first contact changes everything. Who wouldn't feel a shiver at the thought of an artificial relic, billions of years old, carrying messages from extinct civilizations, or scouting for habitable worlds? But let's ground this in the science, peeling back the layers with a critical eye. The sunward plume, that striking teardrop shroud captured by Hubble, might seem anomalous, like headlights beaming forward, but it's explainable through natural processes. As 3I/ATLAS races inward at a steep angle, gas jets on its sun-facing side eject dust particles that curve under solar radiation pressure, creating that forward-facing fan. The faint tail trailing away? That's the classic solar wind effect, just subdued by the comet's composition or activity level. No need for thrusters or sails. Physics alone suffices. Similarly, the CO2 dominance puzzled at first, but hypotheses like formation in a CO2-rich zone or a crust-trapping water ice provide solid natural explanations, backed by comparisons to rare solar system comets. Orbital data adds another layer of reassurance, or disappointment, depending on your perspective. The hyperbolic path fits ejection from a distant star shaped by gravitational perturbations over eons, not deliberate navigation. No unexplained accelerations like Oumuamua's subtle non-gravitational push, which Loeb once attributed to outgassing or artificial means. 3I/ATLAS follows gravity's script faithfully. Martian observations reinforced this. Spectra showed expected volatiles, no anomalous signals suggesting technology. Yet, the debate rages because science thrives on questioning. Loeb's ideas, while fringe, push boundaries, forcing rigorous testing that advances our understanding. Historically, this isn't new. Oumuamua's odd shape and acceleration sparked similar furor, with Loeb's book Extraterrestrial arguing for artificial origins, met by counter-arguments from astronomers like Matthew Knight, who favored natural hydrogen ice models. Borisov, more comet-like, quelled some speculation, but highlighted how interstellar objects vary, fueling theories about diverse origins. For 3I/ATLAS, the reddish, organic-rich surface, dark as coal, reflecting mere 5% of light, mirrors cosmic wanderers exposed to radiation, not polished alien hulls. Emotionally, it's a tug of war, the romance of discovery versus the discipline of evidence, hope clashing with humility. Bolder proposals emerged from this speculation. Loeb suggested repurposing NASA's Juno, orbiting Jupiter, for an intercept, a slingshot maneuver in late 2025 to chase 3I/ATLAS outward, potentially rendezvousing in early 2026. Calculations show it's feasible with Jupiter's gravity assist and an Earth flyby, but Juno's fuel reserves and design limitations make it risky. NASA hasn't bitten, opting to conclude Juno's mission by plunging it into Jupiter. Still, it illustrates our eagerness. A flyby could image the nucleus, sample the coma, answering chemistry questions definitively. If artificial, we'd know. If natural, we'd gain priceless data on alien worlds. Looking ahead, missions like ESA's Comet Interceptor, set for launch in 2029 with JAXA, embody proactive dreaming. Parked at Lagrange Point L2, it'll wait for the next suitable target, perhaps another interstellar comet, then deploy 3 probes for multi-angle scrutiny, capturing dust, gas, and images up close. This what-if mindset prepares us. If one day an object does scream artificial, we'll recognize it, not dismiss it. But for now, 3I/ATLAS remains a natural marvel, its peculiarities explained without invoking extraterrestrials. The tempo here balances intrigue with reason, a dance of dreams and data. If this sparks debate in you, drop a comment. Natural or artificial? What's your verdict? Share to keep the conversation alive. As we turn from speculation to the future, let's explore what horizons await this cosmic traveler. As 3I/ATLAS plunges deeper into the inner solar system, its story is far from over. It's merely entering a climactic phase that could reveal even more about its enigmatic nature. As of October 14th, 2025, the comet has vanished from Earth's view, swallowed by the sun's glare in a phenomenon known as solar conjunction, where its position aligns too closely with our star for safe observation. But this blackout, lasting until early December, doesn't dim the anticipation. Instead, it heightens it, like the pause before a symphony's crescendo. On October 30th, 3I/ATLAS will reach perihelion, its closest solar approach at 1.4 astronomical units, about 130 million miles, where the sun's heat could intensify its activity, potentially causing dramatic outbursts or even fragmentation. Avi Loeb speculates on whether it might break up under thermal stress, a fate that could scatter debris and expose inner layers for study. Imagine the drama. An ancient wanderer, resilient for billions of years, now tested by our sun's fiery embrace, possibly shedding fragments that become meteor showers in distant futures. Post-perihelion, as it swings outward, telescopes like JWST and Hubble will resume watch, tracking changes in its coma and tail. Expect brighter displays if water and dust release ramps up, offering fresh data on its composition. The emotional undercurrent? This phase symbolizes transformation. The comet, altered forever by our system, carrying bits of solar influence back to the void, a two-way exchange between stars. Broader implications loom. These visitors could carry prebiotic organics, hinting at panspermia's role in seeding life across the galaxy. If 3I/ATLAS's organics match Earth's precursors, it bolsters theories that life isn't unique to us. Astronomy's future brightens with tools like the Vera C. Rubin Observatory, slated to detect dozens of interstellar objects yearly once operational, turning rarities into routine studies. Missions like Comet Interceptor prepare for intercepts, waiting at L2 to chase the next one, deploying probes for intimate encounters, dust sampling, high-res imaging, gas analysis. This readiness evokes hope. We're no longer passive observers, but active explorers, poised to snag samples from other stars without leaving our system. What secrets might the next visitor hold? Perhaps clues to exoplanet formation, or evidence of alien biospheres through unusual chemistry. If one proves artificial, it could redefine existence. But even naturally, these objects teach humility, reminding us our solar system is one among trillions, interconnected in the galactic web.